So welcome to Electron 6LA, and you are watching PYQ of Signal Systems of our semester 2024-25. Okay. So in this video, the last two long questions we will be discussing. Okay. So let us begin our discussion. The first question is that by using the graphical method, find the output sequence, that is y of n, of the LTI systems whose response h of n, that is the is given, and x of n also given. So x of n is given as 052 and h of n is given as 111. So we need to find out the output. Okay. So let us check that. So x of n, that is the input is 052. Then h of n, the input that impulse response is your 111. Okay. So now this is the conversion formula, that is the output. So y of n is equal to x of n. This is the convolution integrals h of n. So you need to find out the convolution of the two sequence, that is x of n and h of n. Okay. So this is the formula for finding out the convolution. So y of n equal to summation of k from minus infinity to plus infinity x of k h of n minus k. Okay. So now the what is the length of the input sequence? That is L equal to 3. This is the input sequence length. So it is 3, and the length of the impulse response, it is also 3. Okay. So what will be the output? The length of the output will be L plus M minus 1. Okay. So the length of the output, that is N equal to L plus M minus 1. So we will get 3 plus 3, that will be minus 1, that will be 5. So we have the output length, we have calculated as a 5. Okay. So let us check what is the means starting point of the output sequence and the ending point of the output sequence. Okay. So let us take that. This is the input sequence. So this is the this starting point is 0. Okay. Here also the starting point is 0. Okay. And the ending point is here, that is the 3. So this is 0, 1, 2. So sorry, ending point is 3. Here also the ending point is 3. So you can write x of L, that is the left side security is starting from 0. So x of L equal to 0. What is x of R? So x of R equal to right hand side, it will end at 2. Okay. Similarly, h of L, what is h of L? It is 0, the starting point, and ending point is your h of R, that is 2. Okay. So based on this, we will calculate what will be the starting point and ending point of the output sequence. Okay. So let us check that. So starting point is here, that is the y of L equal to x of L plus h of L. So x of L equal to 0, y of L, h of L is also 0. So 0 plus 0, it will be 0. Similarly, ending point y r, that will be x of r plus h of r. So x of r, that will be 2, h of r equal to 2. So that is the 4. Okay. So in this case also, the starting point is 0 and ending point is 4. So total number of sequence here is 5. Okay. So length of the sequence will be 5. So y of n is the formula for convolution. So x of k, h of n minus k. Okay. So let us take n equal to 0 over here. So n is ranging from now. It will be ranging from 0, 1, 2, 3, 4, and 5. These are the n value. Okay. Sorry, 0, 1, 2, 3, 4. This is not. So total number of the length of the output will be 5. Okay. So first we calculate what is at n equal to 0, n equal to 1, n equal to 2, n equal to 3, and n equal to 4. Okay. So let us check. So it is for n equal to 0. So n equal to 0 will be put. So it will be h of minus k. Okay. So this is the means reversal. So let us take or folding. Okay. So this is h of k. So let us find out what will be here h of minus k. So h of minus k is the means folded version or reversal version of this. So about origin. So about origin you have to fold. So it will be 0. Then this one comes over here. This 2 comes over here. Okay. So it will be 0, minus 1, and minus 2. Okay. So this is our h of minus k. So it will be 0, minus 1, minus 2. Okay. So that will be multiplied with x of k. So what is x of k? So this is our x of k. So this x of k and h of minus k will be multiplied. So you can see what are the common points are there? Only 0. Okay. It is 0. So it is also 0. It is also 1 into 0. That will be 0. Okay. So the y of 0 equal to 0. Okay. So that 1, it is 5. There is no sequence at 1. So there is no sequence at 2 also. Okay. So that is why only common multiple will be multiplied. So there all other it will be 0. Okay. So 0 it is 1. At 0 it is 0. So 0 into 0 it will be 0. Okay. Now we need to find out what is y of 1. Okay. So y of 1 at n equal to 1. This is y of 1. So x of k, h of 1 minus k. So how to find out h of n1 minus k is obtained by shifting h of minus k towards the right by 1 unit of time. Okay. So let us shift that by 1 unit time. So this is our h of minus k. Let us shift this by 1 unit in time. So this will be h of 1 minus k. So we have shifted this towards the right by 1 unit in time. Okay. So that will be minus 1, that will be 0, that will be 1. Okay. So now it will be multiplied with x of k. Okay. So this is multiplied by x over the, so these two will be multiplied. You can see the common points are that common points are 0 and 1. So 0 it is 0, at 1 it is 5, at 1 it is 1. So 5 into 1 that will be 5. Okay, so you can say that will be 5. So y of 1 equal to 5. Next is at n equal to 2. So n equal to 2, this is the formula. So that will be, we need to find out what is h of 2 minus k. So h of 2 minus k is obtained by shifting h of 1 minus k towards the right by 1 unit in time. So h of 1 minus k, that will be shifted towards the right by 1 unit of time. Okay. So this is the, so it will be minus 2, sorry, 1 unit of time means this will right shifted. Okay. So that will be 0, 1 and 2. Okay. So this is 0, 1 and 2. Amplitude are same. That is the, we have to shift the time axis. Okay. So now this h of 2 minus k will be multiplied with x of k. Okay. So that will be multiplied x of k. So this will be multiplied x of k. So what are the common points? All are common points. So 0, it is 0. So that will be 0. Then 5 into 1, then 2 into 1. So that will be 7. Okay. So 5 plus 2, it will be 7. Okay. So this is our h of 2 minus k. That will be obtained by multiplying shifting h of 1 minus k. Then it will be multiplied with x of k. Okay. To find out what is our y of 2. So this is our y of 2. Okay. Next is our y of 3. So at n equal to 3, this is your h of 3 minus k you need to find out. So h of 3 minus k is obtained by shifting h of 2 minus k towards the right by 1 unit of time. So that will be h of 2 minus k, that will be shifted towards the right. So you can see it will be 1, 2 and 3. Okay. So that will be our h of 3 minus k, that will be multiplied with x of k. So you can see at 1 it is 5, at 1 it is 1. So 5 into 1, then 2 into 1, that will be 5 plus 2, it will be 7. Okay. Last thing is there at n equal to 4. So at n equal to 4, it is n minus 4, so n equal to 4. Now, so h of n minus 4 minus k is obtained by shifting h of 3 minus k towards the right by 1 unit in time. Okay. So this is our h of 3 minus k. So it will be shifted towards the right. So that will be 2, 3, 4. Okay. Now it will be multiplied with x of k. So this is our x of k, that will be multiplied. So that is the common point, you can see only 2. So it will be only 2. Okay. So this is so we have calculated all the means 5 values. So that will be y of n equal to 0, 5, 7, 7 and 2. Okay. So this is the graphical representation. Okay. Now you need to recheck. Okay, so for checking, you can see this is the output. Now you can recheck. So h of n kept these are 1, 1, 1. X of n is 0, 5, 2. Just multiply. So 0, all are 0. Then 5 into 1. So 5, 5, 5. Then 2 into 1, 2 into 1, 2 into 1. This will be 2. Then add diagonally. Okay. So first one is 0. So this is 0. Second one is 5 plus 0. That will be 5. Then 5 plus 2 plus 0. So this will be 7. Now 2 plus 5. It will be 7. Last one is 2. So our assumption or our answer is correct. Okay. So this is a 16 mark questions. Okay. So next is your last 16 mark question will take. So this is the last 16 mark questions. So determine the Fourier transform of the double exponential poles which function is given by x of e to the power minus at where a is greater than 0. Also draw its amplitude and phase spectra. This is the 16 mark questions. Okay. So x of t e to the power minus at. So you can see t is equal to, for minus infinity to 0 it will be t, because for minus infinity to 0 t is minus t. Okay. For you can see over here, for this t, that will be mod t, so equal to minus t for t is minus infinity to 0. So minus t into minus a, that will be a into t. Similarly, for 0 to infinity, this t mod equal to t. Okay. So this positive, so that will be minus a t. Okay. Now this is our x of t. Okay. Let us put the Fourier transform over here. So x of omega, the Fourier transform minus infinity plus infinity x of t e to the power minus j omega t dt. So we need to calculate. So from minus infinity to 0, it is e to the power 80. So in place of x of t, it is e to the power 80. then e to the power minus j omega t. Similarly, for 0 to infinity, it is e to the power minus 80. So e to the power minus 80 into e to the power minus j omega t dt. So let us take common. So t common, e to the a minus j omega into t dt plus minus a plus j omega into dt. So let us put the means calculate these values by integrating this. So e to the power of this will be integration minus a j omega t by a minus j omega. So minus infinity 0. Similarly, we have 0 to infinity. Just put this value 0 in upper limit and lower limit. So you can first upper limit, that is, then minus of lower limit. Similarly, this one is a e to the power minus infinity, we put over this infinity, then minus e to the power 0. So this value you can see e to the 0 it will be 1, this will be 0, okay, because it is e to the power of minus infinity, that is 1 by infinity, that will be 0. So it will be 1 by this term, these two terms should be vanished. This one and this one is 0, okay. So we have left with these two terms, okay. So that will be 1 by a minus j omega plus this minus and minus it will be plus, so 1 by a plus j omega. Just cross multiply it, we will get this question. So this is our x of omega, okay, or x of j omega. So we found out this is the Fourier transform. So next question is you need to draw the amplitude spectrum and the frequency spectrum or phase spectrum, okay. So you can see what is the means amplitude spectrum. The amplitude spectrum is x of omega. It is 2a by a plus omega square that we have calculated over here. Now the peak value is at omega equal to 0. The peak value is 2 by a. Okay. So that is the peak value. Next is the phase spectrum, it will be 0 degree because there is no imaginary term is there, no j term is there. So that is why the phase spectrum is 0 degree. So you can draw, okay. So you can draw it like way. So this is our amplitude spectrum, okay. So this is the amplitude spectrum. What is the peak value? The peak value is here 2 by a. So this is that actually peak value is here 2 by a, okay. 2 by a, okay. So this is omega, this is the magnitude, this is amplitude, this is x of j. Okay. So this is the amplitude spectrum. The phase spectrum you can draw. Okay. The phase spectrum you can draw. This is the suppose minus 10 to plus 10. Okay. These are the, this is the value at 0. Okay. This is the 0 value. Okay. This is 0. This phase is minus 10 to plus 10. At 0, this is the means phase spectrum. So this is our x of omega. Okay. So we can draw this way graphs, but just this actually this dotted this double line sided line, the double line is a or bold line is the thing when phase spectrum, when this 0 phase spectrum is at 0. Okay. So this is the means all the question we have discussed, okay, of this odd semester 2024-25, okay. In the next class we will see the event semester 2024 and 25, okay. So thank you for watching this video. These are our reference, okay. So if you have any doubt, you can free to ask me in the comment section, okay. So thank you all, have a nice day.